So I'll just get started. So an ischemic stroke is essentially just a blockage of a cerebral blood vessel that reduces blood supply to an area of the brain termed infarct core, which you can see in this image here. So 1 in 4 people will have a stroke in their lifetime, and as such, it is the second leading cause of death and leading cause of disability worldwide. So even in patients that survive the initial stroke onset, they're at risk of a number of persistent complications. Particularly, a history of stroke actually doubles a patient's risk of developing dementia. So we don't currently know what links these two mechanisms. However, secondary neurodegeneration has been named as a key driver of the process. So secondary neurodegeneration just encompasses this loss of brain tissue in regions distal from that infarct core. So as you can see in this image here, we have the infarction here, and then we get brain tissue loss in regions like the thalamus and hippocampus, regions that are connected with functional outcomes. So SND occurs at delayed time points, so weeks to months following stroke, and as such there is a wide therapeutic window for potential intervention. So these regions also share pathological features with neurodegenerative diseases, particularly neuroinflammation. So the reason why I say neuroinflammation particularly is because we've actually seen an increase in inflammatory molecules within these regions prior to that decrease in brain tissue. So that's kind of where my project comes in. So we really wanted to understand the long-term implications of inflammation in these distal regions following stroke and see how they link with this kind of functional outcome. So in these graphs here, we're just looking at pro-inflammatory markers within the brain, so particularly within the thalamus, which is just one of those distal regions that are readily affected. So the kind of main findings that I've seen here is at 15 months, we see an increase in the level of these pro-inflammatory cytokines in our control group. So this was unexpected, but we think that it is likely due to inflammaging. So inflammaging is just essentially, with age, we see an increase in the baseline levels of inflammatory cytokines within the brain. Interestingly as well, we did see a decrease in the level of these pro-inflammatory cytokines in the stroke 15-month group. And we thought that this might be suggesting that there's some post-stroke immunosuppression. So sometimes following stroke, we see this kind of decrease, like overall decrease in the inflammatory molecules within the brain. So following on from the brain, I also wanted to look at the changes in the blood. Now the reason that we're particularly interested in this is obviously within patients we can't look at their brains, but we can in fact take their blood samples. So we thought if we saw correlations with changes within the blood and within the brain, that we are essentially getting a window into the damage within the brain. And interestingly, we did see an increase in the level of anti-inflammatory cytokines within the 15-month post-stroke group, which you can see in this graph here. So that is further suggesting that immunosuppression, because immunosuppression is kind of characterised by this decrease in pro-inflammatory cytokines, which we've seen in the brain, but then also an increase in anti-inflammatory cytokines, which we've seen here in the serum. So it's really kind of giving us a snapshot into long-term neuroinflammation and potentially how it is linked with secondary neurodegeneration and functional decline. So kind of what's next for my project? So I just wanted to start by saying this is one of the first studies investigating inflammation and SND at these delayed time points following stroke. And as such, further tissue analysis is required and is ongoing. Particularly, I'm really interested to see if that brain tissue loss is linked with functional and behavioural outcomes following stroke, and if that decrease in inflammation is also related to that tissue loss and that functional outcome. And now I like to end all of my presentations with kind of looking at the bigger picture, because I think as researchers we kind of get stuck in the nitty-gritty lab work and not really thinking about what the findings we see actually mean. So for me, it is the hope to garner a greater understanding of the long-term implications of SND and neuroinflammation and how this may drive functional decline following stroke. And I really hope that we can potentially develop targeted treatments to improve stroke outcome. I'd just like to finish by acknowledging my supervisors Renee, Lindsay and Beck, as well as the Translational Neuropathology Laboratory and Team Stroke, as well as the NRF for supporting my research. Thank you.